good morning. So as per introduced by Bu Rati, so I will present my talk today, which is statistical method for data science. I will share my screen now. Sorry, my laptop sometimes is hanging. It's an old one. Okay. So today's title is statistical methods for data science. Okay. First, I would like to introduce myself. Okay, as have been introduced by Bu Rati. Okay, I'm a senior lecturer at University Malaysia Pahang. It's a state in Malaysia, a very small university. So I received Ph.D. from USM and master in UPM and also degree in UTM. All my degrees are from Malaysia. So my research involving data analysis, but mostly in machine learning. Application in machine learning, applied statistics and data mining. So down there, I have include my LinkedIn, research kits, my email and my YouTube channel. So if you're interested to connect with me, you can find me in my LinkedIn or follow me on research kit or email me if you have any question regarding machine learning. Okay, because that's my field actually, machine learning. Also, you can view a few of my videos that I made in my YouTube channel. My name on the channel is Dr. Data. Okay, it's kind of funny name. Basically, in my YouTube channel, I share video on the data warehouse and big data. Okay, that's a new subject that I have to teach for this semester for our undergraduate study. We also have the new program here. It's called Data Analytics. So the student also new. They are second year students. Not graduated yet. They still have 3 more semester. So they are first batch. So the program also the new one. So I just actually joined University Malaysia Pahang. Previously, I was in KL for 5 years. Alright, so enough about me. So we're going to go for the details on the topic itself. Okay, so before we go further on the topic on the statistical method, I would like to introduce a little bit about data science because that is part of our topic today. Okay, as you know, data science is an essential part of an industry today. That's why a lot of universities started to offer this course. In Malaysia, our university is the first local university that offered data analytics courses. Previously, there's a lot, but everything is private university. There is no local university yet, so we are the first one. And then, because this course is so popular, it's on demand from the industry. The popularity has grown over the years, and more jobs are created involving these data scientists. Yeah, in Malaysia, I'm not sure about Indonesia, but in Malaysia, the data science job. Okay, if you work as a data scientist or data analytics, salary is actually much higher than engineering, than become engineer. Previously, I taught the engineer student, so I always encourage they took the engineer course. Okay, and then once now I changed the university, I changed the field already. I changed student. Now my student is in data analytics, so I promote data analytics more compared to engineering, because engineering actually is a very tough course, and in Malaysia it's a 4 years compared to data. Data is only 3 years and 3 years and a half. Okay, but after you graduated, the job offered is more on data compared to other fields, and the pay also, the salary also highest. So that's why some of the website is called data scientist as the most sexiest job in the century. So what the sexiest about it, the paycheck lah. The paycheck is really sexy, okay, because it's pay you really high, okay, in our country. Okay, I'm not sure if is it the same in Indonesia. But before before we going further, lah about the data science. Okay, let's go to this website. Okay, if you have another device, handphone, or you can change the apps for a while. So you go to this website, www.menti.com. Okay, you use this password. Okay, I want you to answer what is the data science. I want to test your understanding on the data science without Googling or Google the meaning of data science on the Google or Wikipedia. All right, so I give you some time while I open the website. How to change? Wait, sorry. I am not very sorry, I'm not very familiar with the Zoom. Usually I use Google Meet or Microsoft Team for the class. So how you change this layout? Sorry, I don't know how to use this.
Just close the share screen and then change into the website.
Change. Oh, stop sharing.
Yes,
Okay.
stop sharing.
I cannot find the button. Sorry. Okay, so I want to share another. Okay, so there's a few answers there. Okay, so we wait for others to answer. Yeah, some answer a combination of statistics, mathematics, and programming. Okay, some answer, wow, very long answer. Okay, data science, knowledge about data, slice key, multi-disciplinary study. Okay. Data interpreter is process analytic. Okay, I think most of you got the answer correct lah. Most of you understand what is the data science. Okay, I can sum up lah the definition from your answer here. So it's a multidisciplinary study. It's a combination of math, statistics, but less math, more statistics actually. It's an interdisciplinary field, so it can come from any field. Okay. Also, the most important in data science is actually statistics and computer, the algorithm, that programming, everything that you need to learn. Maths is not much. Other than that, it involving data, of course. That's why it's called data science. And then from the all the data that we gather, we need the algorithm, okay, from the computer to solve the study, certain problem from the study, and then we produce the output in terms of visualization, in terms of graph and everything. So that's his data science. Basically, or whatever you answer here is correct. Okay, there is no wrong answer. It's open-ended questions. Okay, so go back to the. Here we go. Back to the slide. Okay, this is the. Okay, the next slide is actually a comics that I found online. It's kind of funny because it's true. Okay, previously data science is not much popular as statistics. People know statistics, but they just ignore it. They feel like statistics is a boring subject. This don't have any what we call it use in the daily life. So everybody like yeah, you learn statistics. So what you want going to work after that? So that is totally underrated field lah. So then it comes all involving data, especially with the increasing our internet, with the apps, with website, with sensor, with big data. So statistics become popular. Everyone going to use it, and it has rebrand into data science. So in this comics, so statistics, everyone is know it. When it rebrand into data science, everyone, wow, look at that. So it's a lot of people pay attention to data science. So it has gained popularity. But if you just said, I study statistics, nobody going to listen to you. Okay, so you have to, I study data science. So wow, that's a very huge field, salary field. So it's good field. So everyone going to praise you. So that's a funny thing about this comics. All right, so why is data science? There is 4 reasons here. Okay, first we want to find the leading cause of a problem by asking the right question. So of course, for the study, any study, you have to start with the problem and you want to solve the problem of the study. And then from the problem, you're going to get the data. And from the data, you're going to perform exploratory study on the data. And then after we get the data, we study the data, we modeling data using the algorithms. And last one, we will communicate and visualize the result via dashboard, graph, and everything. Okay. Okay. So there is 10 statistical techniques that scientists need to master. This Google or internet search. Okay, if you search it, this is most statistical techniques. By the ranking, regression is the most popular. Okay, second is classification. Third is resampling methods. Four is subset selection. Five is shrinkage. And then we have dimension reduction, neural net models, tree-based methods, support vector machine, and unsupervised learning. Unsupervised is including everything under that. Classification is under KNN and everything. But the most popular is linear regression. That is a must know for a data scientist. If you don't know linear regression, so you should be ashamed by that lah. Okay, so that's because it's so popular. Okay, that's why I'm going to highlight on this topic today, linear regression. For the rest of the method, maybe you're going to learn during your study on your course of your degree. Okay, why linear regression? Because it's widely used, it's run fast, it's easy to use, it's highly interpretable and basis for many other methods. Okay, because it's more popular and easy to use. Yeah. This meme for internet. Okay, actually you can find linear regression everywhere because it's so popular. Okay, for today's under linear regression, I'm going to divide it under 4 subsection, which is we're going to start with correlation, and then how to build the simple linear regression model. Then we go to multiple linear regression analysis, and the last one is model selection. It's not really the long topic, it's very short one. So before we going any further, we're going to start with the first one, correlation. So I want to introduce a little bit about linear regression. Okay, linear regression is one of the most common statistical model approach used in data science. Yeah, I already keep repeating that. Okay, it's commonly used to quantify the relationship between 2 or more variables. And in data science application, it's very common to be interested in the relationship between 2 or more variables. Okay, so the keywords here, the relationship. So the linear regression is studies about the relationship. Okay, why this relationship matters? Okay, because the answer here, we can't access information from the future. So the only thing that we have is the data. So the data, we have contains of variables. So we want to know what is the relationship between variables so we can predict the whatever you want to know in the future. Okay, so linear regression is a part of prediction model. So you can use to predict by using regression. So from to build the model, we need the data. So the data, from data, we have all these variables and we want to study the relationship between them. Okay, so that's the only thing that we know. Okay, let's example. We want to predict the price of a house. Okay, the challenge here. Okay, let's say you are a real estate agent. Okay, you want to predict the price of a house. Okay, you want to sell a house. If you sell the house too expensive, no one going to buy the house. But if you sell the house too cheap, you're going to lose. Okay, because the house is not supposed to sell that kind of price, so you lost. Okay, so you want to know what is the suitable price so that you have your potential buyer and you don't gain loss in your selling. So this is where integration is needed. So we can predict the suitable house price so you don't sell the you don't gain the loss from the selling house and you get the buyers to buy the house. Okay, let's say from this case study. So first thing, okay, we're going to set up this case in Python. Okay, I assume everyone know Python here. Okay, the easy ways to learn Python, okay, actually from Jupyter Notebook atau on the new one. Okay, I found this, the Google Colab. I'm not sure if you're familiar with this. I show this one. Okay, so this one, Google Colab. So if you open it, it's not a Jupyter notebook, but it's from Google. So you can learn run Python from here. It's very easy. It's actually very similar with Jupyter notebook. Okay, if you open it, so there is a few example Python code here. So overview of features of collaborator and markdown guide, charts, external data, everything. So this is some examples. Okay, so you can also upload it or reload it from your Google Drive. Okay, also you can access it from GitHub. Yeah, there's a lot of Python code in GitHub. Also the data, mostly the data that I use in my class is from GitHub. Okay, let's say we just close this one. Okay, or you can go to Google Snippet. You can see everything in the Google Colab here. Yeah, there's a lot. You can learn machine learning in here and everything. Okay, if you go to the started menu. Okay, for simple integration today, I will show you. Okay, I already key in the code in my Google Colab. Okay, so this is the code. Line by line. Okay, you can just add code or you can add text. Okay, let's say you want to add text, you can say lah, we want to import data. So it's a text. So it will appear as a text. Okay. So this is an import data. Okay. Any data analysis always started with the import data, obviously lah. So we want to load data. So in Python, we are going to start with import panda, std, and then import numpy. We want to show you the plot of scatter plot later. So we're going to use the matplotlib. Okay, sorry. And then the last one I import cbond. This is for the heat map. Okay, the data that I use here is from the GitHub. Okay, so we're going to import from this GitHub website. Okay, if you open this, link, so it will bring to you the raw data. Okay, this is the data that we use for this study. So the price of the house, how many bedrooms, how many bathroom, square feet living, square feet lot, floors, condition, grade, square foot above, square feet basement, and zip code. So all this data involving the selling, we want to predict the housing price. Okay, the Y variables, the predictor variables is the price. Okay, the rest is the X. Yes, there's a lot of the variables that maybe we don't know yet. Okay, maybe affected the price house selling. Okay, so there's a lot of variables. Okay, so we want to show you the data set here. So you can just run this very easy and very fast. You just can click there. So you're going to run the Python code and give you the output down there. Okay, this depends on your internet connection actually. Okay, so if your internet connection is very fast, so you can get in a few seconds. So this is the data. It's become structured. Okay, like table. So it's more. Baru setelah laporan masuk minggu kedua nilai sudah harus bisa masuk. So it's more structured lah. Okay, and kemudian then, laporan semuanya sudah dibuatkan oleh Dr. Farid di server, ya. Sorry. Okay, so we back to the slide. Okay. Okay. So. Okay, now we want to go to the correlation. Okay, correlation, coefficient. So after we set up the Python, the data set, so we want to study the first. We want to study the correlation before we can build the model, because we want to know what is the relationship between these variables. There's a lot of variables down there. So let's say, first of all, we need to know what is the correlation coefficient itself. Okay, first, this correlation is introduced by this person. It's called Carl Pearson in 1900,000. So, 19,000, I don't know. 1900 tahun dahulu lah. Okay, so it's very long time ago. So that's person. So is his name is this correlation and after himself. Okay, person. So we call it a Pearson coefficient correlation right now. Okay, the study the equation is used to find the correlation between variables. It's denoted by the symbols. So the symbols is big R for population and small r for the sample correlation. So if you learn statistics, the basic statistics before, you should know how to differentiate between population and sample. Okay. Okay, this coefficient correlation is used to indicate the linear degree of scatter plot, and the value measure how strength of the relationship between the variables. Okay, this coefficient correlation is numerical values. Okay, it's between -1 and until 1. So it cannot be more than 1. So if you get the value 1.1, 1.5 is wrong. So it cannot be more than 1. It also is an independent unit of scale of the variables. That means it don't have a unit, it's just dimensionless. And then the correlation coefficient is easily affected by all this. So that is why after you get the value of correlation, you should check with the scatter plot also lah, because we want to know if any plot that is outliers. Okay, if the outliers, that means your value of correlation something will be affected. Okay, the last one, the nearer the value to 1 or -1, so we said that it has a highly correlated. Okay, so how we know? Okay, this is a table. This table here shows the strength of correlation coefficient. So we have -1 until 1. Okay, for if the R is equal to 0, that means no correlation between these variables. Okay, and then if -1 or 1 is a perfect correlation. Okay, if negative is negative, perfectly negative correlation. If positive is perfect positive correlation. It's the same for both sides. Okay, if between 0 until 0.5 is a weak. 0.5 until 0.7 is moderate. Okay, 0.7 until 1 is strong. So this is how we classify our coefficient correlation based on the scale. Okay, this is based on the plot. Okay, if R equals to 1, usually the line is straight line. Okay, same as goes to -1. The difference is positive and negative. So positive is straight up plot and negative is down plot. Okay, 0.8. So the scatter plot is like this. Mostly 0.4, 0, no correlation. So the data scattered all over the place. Okay. So we also, besides scatter plot, we also can display the correlation on the heat map. Okay, if you run this Python code, okay, later maybe you can try using the Google Colab. I already shared this my slide with the Bukyat Rati, so I think she will share with everyone. Okay, so you can run this code, so you will get the same output here. Okay, this is the heat map of the all the variables in our study. Okay, about now. Okay, about the price of the house and all the variables. Okay, how to read this heat map? Okay, the value is show the coefficient correlation. Okay, so the diagonal value you see all one. Okay, because they cannot correlate with itself lah. Okay, and the last one in our current color, the lighter boxes represent a higher correlation. Okay, if you can see, so the lighter one, so we get, let's say here, square foot above and square foot living is highly correlated is 0.88. Okay, other than that, is very not highly correlated. It's such as zip code. It's not highly correlated with everything. Okay, it's almost zero. And that's why it's darker. It's almost black color. Okay, the rest I think also very weak. Okay, square living and bedrooms it's not so high correlation, but square living with price is quite high. This one is 0.7 is quite high. Okay, you can see this variables with variables and variables with price. So how they correlated with each other. Okay, after we study the correlation, then you can also plot the scatter plot by using this Python. Okay, you can run this also in Google Colab and you will get this plot. Okay, so this is how our data look like in the scatter plot. So it's scattered, mostly linear, but there, if you notice, there are some outliers. Okay, actually, from here there's one outliers, so probably the correlation might be affected by this one. Okay, outliers, there's some outliers out there. Right. Okay, there's terms maybe you just heard or in today's talk. Okay, spurious correlation. Okay, spurious correlation, this is in statistics. Okay, spurious correlation or spuriousness as it is called. This refers to the connection between two variables that appears has a relationship but is not. Okay, spurious relationship will initially appear to show that one variable directly affects another, but it's not in the case lah. Okay, if you open this website, okay, tylervision.com. So this website is dedicated to spurious correlation. You can see many variables that are not related to each other, but it's very highly correlated. Okay, if you take the data, for example, I take one example from this website. Drownings caused by an accident involving a fishing boat with Apple stock price on January 1st. Okay, it is not making any sense. How you drowning cause of an accident because you are fishing boat, and then the Apple stock price on January 1st is going up because you accident. So it's very uncorrelated variables. The variables is not related to each other. But if you take the data, both from the drowning cause and Apple stock, it's a highly correlated. The correlation is 0.78. So it's strong correlation there. But the variable is not related at all. So this is what we call as a spurious correlation. Okay, probably some of you just heard this today, but this is really important in statistics. Okay, not everything that has a higher correlation is correlated. There are some variables that are not making any sense, but it's a correlated various correlations. Okay, as a reminder. Okay, before we go to the main one, okay, how to build simple linear regression model with Python. Okay, as you know, linear model is an equation. Okay, first we have variables. Okay, we want to study if the variables is correlated with each other. Then from the data, okay, if you know the data, the variables is correlate, we want to build a model. Okay, an equation actually. So linear model is an equation. Okay, it's describe relationship between the variables. Okay, after we study the relationship, now we want to get the equation. Okay, let's say from the example just now, okay, we want to predict the price of house. Okay, we have the x variables, which is the size of house. So we have a function, so fx, so it become a predicted price. We can get the predicted price from the this linear equations. Okay, to build this linear model, basically we use the if you know the Einstein straight line equation, so y equals to mx plus c, okay, or b is just a sign, it's just a symbol. Okay, so b is intercept, m is a slope. So this is where the linear regression come from. It's from the straight line equation. Just the model rewrite a little bit different, but it's almost the same. So y is your output. Okay, b in your intercept now is become beta naught. Your slope has become beta 1. Okay, so we in this linear equation model, we want to find beta naught and beta 1, same with the linear equation model. Okay, b naught is your y-intercept and b1 is your slope. So to know how to know your model is your equation is good, so we have to make sure the difference between actual and our predicted value, the distance is minimized as we can. Okay, this one. Okay, finding the best of fit on model. Okay, how we describe how well our linear model. So we see here, let's say y head here. Okay, y head is a predicted value. Okay, y the normal y is the actual value. So the difference between the predicted and the actual, we call it as a residual. So we want to reduce this gap between predicted and actual. So you want to minimize it as small as you can. Okay, if the value of the residual is minimized, that means your model is better. Okay, the distance is not too far. The gap is not too far. If the gap is too far, that means the model is not good. Okay, there's too far, too big, too large value between actual and predicted. So we don't want that, right? Okay, there are another ways to test whether your model is good or not is by using the mean squared error, or MSE. This is a lot of classification model also use this type of method. Okay, it's a measure of the average of the squares of the residuals. Okay, not just for linear regression, it can be also used for classification. Okay, so from the actual and predicted, so you minus, you squared, and you divide by the total number. So the average, basically the average of squares of the residuals. So this is will give you the value of the error. So if the error is very big, so that means your model is not the best fit. Okay. So how to build a simple linear regression model? Okay, in Python we import this using the sklearn. Okay, then you can find the b0 and b1. And then after you find the equation, you can use the equation for prediction. Okay, this is the code. Okay, before that okay, this is the code, but before that, you have to know to train and test. Okay, we are going to, okay, let's say we take one variable only from the predicting the house. Okay. Okay, it's because square foot living has a higher correlation, so we take one only because this is simple linear regression, one variables only. Okay, after this, we going to focus on multiple linear regression, so we can take more variables from the data that we have just now. Okay, so for linear, we only take the square foot living. Okay, for example, so we have these variables data, square foot living and price. So we're going to split this data into train and test. Okay. Okay, first you define your train and test data. So this is a code for Python. Okay, you import the module, can test and split from the sklearn. Okay, and then you define your predictor and target variable. So for your predictor, so your X houses square foot of living, and target is houses price. And then we create the for group for train test split. Okay, this usually some people they use 80 and 20 or 70 or 30. Also you can use 70% and 25. Okay, by default I use 75%, okay, to train and 25% to test. Okay, this is the code for the train test and split. Okay, we can run later in the Google Colab. Okay, the step 2, you build and fit the model. Okay, we import from the sklearn line irrigation. So we got the line irrigation, fit the line irrigation model and print out and show the line of best fit. Okay, this is the output that you should get. Okay, from the scatter plot that we have just now. Okay, this is a straight line. Okay, the model, the equation that you're supposed to get is the intercept is negative 39.163 and the slope is 279.4. Okay, from this equation, we can see that the coefficient B1 of our model tells us that the price will increase approximately $279.4 for every additional square foot in a house. So that's very expensive. Okay, so you can predict, so for 1 square foot is 279. So let's say you want to predict for 4,600 square feet. So you can just use this code LR.predict 4,600, you can get the price for this square feet. Okay. Okay, another way to evaluate the linear regression, okay, beside the mean square error, we also have root mean square error and R squared. Okay, basically root mean square error. Okay, just now you know about mean square error. Okay, root mean square error is just add the root square root function from the mean square error. Okay, so it become root mean square error. Okay, this is another way to find to validate the model. It's same with the mean square error. So the highest the value of RMSE, that means your model is not good. Okay, and then this is also has been used in another classification, not just linear. Okay, if you have nearest neighbor method, you can also use this root mean square. So it's very popular issues to know whether your model is good or not. Okay, this is a Python code that you need to run in order to get the root mean square error. Okay, you have to define your prediction model first. Then you import the module sklearn. And then we pass the test value and the predicted values using this equation, MSE. And then we take the square root from RMSE. So RMSE, the square root of MSE. Then you print the result. Okay, we're going to show you later on the Google Colab. Okay, for R squared, which is also known as the coefficient determination. This is mostly in statistics. But for the classification, we don't use this. This is typically for regression only. Okay, so this is a proportion of variation that explained by linear model. In general, a higher R squared value represent a better fit of data. So if you get R squared 0.9 something and 98%, so it's very good fit. But if you get very low, that means it's not good. Okay, so how do you want to measure R squared in the Python like this? So we import from the sklearn also. Okay, R2 square, we can print the score. So you can see how much the R squared value for your line irrigation. Okay, before I go to multiple line irrigation analysis, I think I show you for a while. To stop share, okay, maybe. Okay, so just now we earlier today we already run this data. So this is your data. Okay, if you don't want to see this data, you can close the box. Okay, so close the box of the data so you can run for the correlation. Okay, this are going to show you the heat map. Okay, the same one that I showed you in the PowerPoint. Okay, then you can run for the scatter plot. Okay, this one also the same one. Okay, in the PowerPoint presentation. This one for the train test plate. Okay, then this one is to find your linear regression. Okay, model is you do want that. Close that. So this is to predict. Okay, if you want to predict 4,600 square foot, so that is your output down there. So your Y or your price is 1,253,577 US dollar. Okay. Okay, if you want to root mean squared, we can run that. So it gives you already. Okay, root mean squared is 254 to 254,000 and 234. It's really high lah, which mean although your these variables, these square foot variables is highly correlated with the price, it doesn't mean these variables in your model. So it's the error is very high. So it's not good for your model actually. Okay, if you're not satisfied the mean square error, you can always check with the R square. So in this example, we got the R square value is 0.49, which is also lower. Okay, it's not good. If not higher than 0.7 or 0.8, it's not good. So 0.49 is very low. So that means this model is not good lah. This variables is not good for our linear regression. So maybe you can test with other variables, but from the just now from the correlation value from the heat map that we get, that the other variable also not much highly correlated. So we can maybe we can conclude variables is the data is not enough or the variables is not. But also the linear model that we built here is only contains one variable only. That's why it's not very give impact to the linear model. Okay, usually in real life, we have to deal with a lot of variables. So to predict the, for example, in this case, we want to predict the housing price, but you only use one variables, so it's not making sense. Then you cannot predict the price based on one variable only. That's why you get the very high error and R squared is very low. Okay, in real life, that's your linear regression making sense. That's why no one actually use simple linear regression model in case study lah. Okay, almost none. So what you need is, so you be back to, okay, what you need is multiple linear regression analysis. This is the most important one. Okay, we will just face the fact. Okay, in real life, we have to get the data, get a lot of data, and your study actually has to involve a lot of variables, not just one. Okay, no one actually use a simple linear regression model in the analysis. Okay, this is the right one, multiple linear regression analysis. Okay, so as you know, as it involves more than one variables, so it's an extension of simple linear regression. From the simple linear regression model equation that we have, y equals to b naught plus b1 s1. Now we have more than one variables. We have two and more. Okay, you can have as much variables that you want. Okay, it's until bn sn. So it's unlimited. Okay, it depends on your data, on your model. Okay, so this is the equation. So you have a lots of constant that you have to find based on your variables. Okay, these are 5 steps to build a multiple regression model. Okay, step 1, you have to identify variables, of course. Let's say you have a data. And then you have to identify which one is a predictor, which one is a target, and which one is your X variable, independent variables. And then you have to check the assumption. Okay, in the multiple regression model, we have 4 assumptions. Okay, I will show after this slide. And then you create the dummy variables and avoid the dummy variable trap, and finally building the model. Okay, let's see the assumption first. So there's 4 assumptions that we need to assume before we build the multiple linear regression model. First, linearity. Okay, in terms of linearity, we have to assume that the relationship between dependent and independent variables should be linear. And then in terms of homoscedasticity, the constant variance of the error should be maintained. And the multivariate normality, multiple regression assumes that the residuals is between predicted and your actual. Okay, that's residual. Okay, all the residuals are normally distributed. And the last one, lack of multicollinearity, that means it assumes that there is little or no multicollinearity in the data. For the 4 assumptions here, the last one, the multicollinearity, is the hardest one to assume, because not all model has no multicollinearity or little multicollinearity. Okay, some of the models, like example that I will show you after this, it a good model, but it has highest multicollinearity. So what we going to do if this thing happen? Okay, so I skip this one first. Okay, we go back to that. Okay, first we're going to implement multiple linear regression in Python. Okay, we use the different data this time. We don't want to use the prices of house. Let's say we have these variables. Okay, also this data I get it from GitHub. Okay, 50 startup CSV. Okay, you can open the data here. Okay, if you don't want the data in the table, you can click raw. And then you can input it, export it to your Python. Okay, to export your raw data in the Python, you have to get it like this. Okay, you cannot export it in CSV. Okay, this is how the data should be in your Python Google Colab data. Okay. What is it? Okay. Okay, so that's data. Here we run it later. Okay, same with the linear regression. So we start with import data set. Okay, we import everything that we want to use, NumPy, Pandas, Matplotlib. So this is a URL for the data. So right now I rename my data as a data set. Okay, I will run it later in the Google Colab. Okay, so we start with data pre-processing after we load the data. Okay, it's a little bit different with linear regression, simple linear regression, because right now we have more variables. So your variables should be in the matrix. Okay, for the simple linear, it can be just an array. So you don't have to make it a matrix. But for this one, because it has a lot of variables, so it's involving matrix. So for the X variables, I take everything, all except the Y. Okay, so that's why -1 here. Okay, for the Y, so I take the last one. Okay, if you get the data, okay, later on I will show you. Okay, then because this data has the categorical variables, which is state, so I'm going to encode the categorical variables into the numbers. Okay, if your data don't have the categorical variables, you can skip this step. So you don't need this step. If all your data is numerical. This is for categorical variables only. Okay, this step. Okay, third, avoiding the dummy variable trap. Okay, this is a step that I mentioned earlier in the modeling multiple regression. Okay, fourth, same with linear regression, simple linear regression, we split into the test and train. And then last, we fitting the model. Okay, fitting the model, we import from the sklearn, same with the splitting test and train. Okay, so after you get the model, you can run this while prediction. So you get the prediction value. Yeah, we show here. Not this one, sorry. Okay. Okay, so we go to multiple regression. Okay, same with previously. So I already have the code in my Google Drive. I already run it. Okay, so we want to save time. So if your internet is okay at your place at university, so this should be not taken so long. Sorry for internet. My house is not very good. I don't know internet, but I found that internet in Malaysia is much expensive and very slow compared to your country. I've been there. I've been to Indonesia for a few times. I've been Bali and Lombok. I really love Indonesia actually, and your internet is very cheap compared to ours. I don't know. We have like worst internet ever. Okay. So sorry about that. So this is the multiple regression model in the Google Colab. Okay, I already paste the code so you can run here. So it will show your data set. Okay, this take a while. So as for now, while running this, okay, we are in our university, we are still learning at home. So I have to work at home because we currently at the emergency lockdown. There's a high increasing number every day of COVID-19. So we have to stay at home. So my student also have to stay at home. So we technically have the virtual class starting from last year, early start March last year until today. So it's almost 1.5 year, okay, online class. So as I said before, our internet here, okay, so slow. Usually you can get this around a few seconds only, so you don't need to wait this long. Sorry about this. Okay, so this is how your data should be like. Okay, same with the data I showed in the GitHub. Okay, so this data, it has a categorical state here. State, New York, California. So this is the categorical data. This is the one that I encode. This or encode because of the category data. So if your data don't have this categorical data, you can skip that part. So in this data that we have here, we want to predict the profit. Okay, so okay, the rest is our X variables. Okay, how much the R&D spend, admin, marketing spend, and state. So this is based on a company. So how much the company make profit based on how much the R&D spend, how much they have to pay for admin, how much they have to spend for the marketing, and which branch of the state lah. Okay, then we run the data here for X and Y. Okay, so this we categorize the data. So X, we take everything except the profit here. So that's -1. We take the column 4. Okay, this is for the encode for the categorical data. Okay, then this one, the dummy. Okay, then when we train and split the train and test. Sorry, forgot to charge my laptop. Okay, and then linear regression model, we build the model. So this is a model. Okay, now we want to have take a look at our y-test and lastly our prediction. Okay, so this is our y prediction based on x-test value. So we get the prediction value. Okay. We back to the PowerPoint. Okay, after building our multiple regression, of course, same with simple linear regression, we want to validate the model. So same, we use R squared, but for now there is an addition. It is a F statistic. Okay, R squared is similar with simple linear regression. So that means the higher value of R squared, the model is good. Okay, the new one, F statistic. So this one is from statistical. Okay, F statistic. So here we can get from the ANOVA or you can get from the OLS. Okay, so you can take a look from the p-value and the F statistic. Okay. Okay, I will show you right now. Not this one. Okay, this one. This is the code. I didn't share it in the slide. Okay. Okay, never mind. I will share this. I think I can share this code in Google Drive. I will share the link to the book Rati. Okay. After this, okay, this is the code that you if you want to run the ANOVA or like regression. So from this code, it will get you the summary of your model. Okay. So here you can get your R squared value. Okay, your R squared is 0.996, which is very high. So that means the model is good. Okay, and then we have the F statistic. Okay, it's more than one. It's very good also, 277.9. And then for p-value for each variable, this is a p-value for each variables. Okay, p-value indicates if the p is smaller than alpha, which is alpha 0.05, which is significant. So p-value should be as small as it can be. Okay, like 0.03. So this value is cute. So 0.6 is not. Okay, any value that has a higher p-value, so we can remove it from our model. Okay, like S1 have a higher p-value, so we can remove this. S2 also 0.461 is quite high. Okay, for S3, you can take this value 0.03. Okay, S4 also okay. S5 is not okay, 0.1. Okay, so that is how we evaluate our model based on p-value and R squared value, also F statistic value. Okay. So we're back to our PowerPoint. Okay, so the last one, how we select our model selection. Okay, so we consider the p-value as I mentioned earlier, displayed by the output. The smaller the p-value, the better the model, yeah, as I mentioned just now. And then we consider the R squared, okay, for simple linear regression model. The higher value adjusted value R squared for the multiple regression. Okay, same. Yeah, that's for simple linear regression or multiple regression. But for multiple linear regression, we have more tips, okay, for choosing the best model. So for each 2k minus 1 possible model, we choose the best model based on the following specifications. Okay, the model has to has lowest p-value. Okay, just as I mentioned right now, from the ANOVA, it has highest coefficient determination R squared, and each process exclude any variable which do not meet this prediction. Okay, just now I showed you the example. If the p-value is high, so we remove the variables. Okay, when p-value is less than alpha, okay, alpha as a default we assume is 0.05, so it indicates the variable is significant. Okay, I already stated that. So of all the considered model, the best model would has the highest R squared and smallest p-value. Okay, I think that's all. But before I end, okay, I want to show you. Okay, in my model just now, even though it has a very high R squared, very high adjusted R squared, okay, 0.993, it has a high F statistic, but you should see the warning down there. Okay, it said that the condition number is large. This might indicate that there are strong multicollinearity here. Okay, I know that we assumed earlier in our model that our model should have little or no multicollinearity at all, but this model has strong multicollinearity. So it's also not good, although there has a R squared highest everything. So it's not as simple as that. You want to select a model or conclude your model is good enough for multiple regression. Okay, what what is multicollinearity first of all? So I back to my slide. Okay, this is the last one. So I'm going back to multicollinearity. Okay, this is multicollinearity. Okay, so it occurs when the independent variables, all your S variables, okay, in a regression models are correlated. So that means the models, the variables are correlated to each other. So if you, there is a little movement for, let's say we have S1, S2, S3, S4, S5, okay, let's say S2, we add a little bit value. So other variables also will be affected, because they are highly correlated to each other. That's why it means with multicollinearity. So this correlation will become a problem because the variable should be independent. It should not be affected by other variables. Okay, it can be fixed. Also, if you want to just leave it there, it also can. If you want to fix, actually it's a very what we can say that on the topic multicollinearity itself, it's a very long discussion. So I just share the short discussion in here because I think we're almost time. Okay, so just I already defined what is multicollinearity. So it causes because of these two problems. First, because the coefficient estimates can swing widely based on which other independent variables are in the model. Okay, it's become very sensitive to small changes. Okay, this is what I just explained. And then multicollinearity reduce the precision of the estimated coefficient. So it will weaken the statistical power of your regression model. So that is very affected. If you don't have change your model, it's good. But if you have a little bit changes in the one variable, the other variable will be affected. That's all. So a lot of other things about multicollinearity, I think maybe you can read it online, or maybe you will learn it later in your senior year during your study. Okay, I think that's all for me today. I have sharing everything that I know so far. Okay, maybe we go to the Q&A session. All right, thank you for your attention.
Okay, thank you, Dr. Azu, for the great presentation.
Okay, welcome.
And then this is the session for Q&A, and I'm pretty sure that the students has already make questions about the presentation. Maybe one of, or maybe who wants to raise hand for asking the question to Dr. Azu? Ada yang mau bertanya?
Kalau mau bertanya dalam bahasa juga boleh, juga bisa. Ya, kita lagi apa itu bilangnya serantau Asia, semua sama saja.
Betul. Jadi silakan untuk teman-teman mahasiswa yang ingin bertanya ke Dr. Azu bisa menggunakan bahasa atau bahasa Inggris juga dipersilahkan. Ada yang mau tanya?
Bu, saya izin tanya, Bu.
Boleh.
Tanya aja, Bu. Linear regresi sebenarnya, Bu, digunakan pada kasus yang bagaimana aja ya, Bu? Apakah hanya untuk menentukan memprediksi value sesuatu gitu, Bu? Kayak contoh tadi itu harga rumah gitu, Bu. Apakah itu ada bisa dalam bidang lain selain menentukan harga terhadap sesuatu gitu, Bu? Terima kasih.
Ya, boleh juga untuk yang lain. Ia memang digunakan untuk prediksi, sama seperti classification punya model. untuk prediksi. Tak semestinya harga rumah. Kalau mau prediksi harga saham, kalau Bitcoin also juga boleh. Kalau yang sekarang ni yang popularnya, saya rasa Bitcoin and cryptocurrency. You boleh guna model linear regression, okay, untuk prediksi you punya Bitcoin and cryptocurrency everything. Thank you for the question.
Sama-sama. Makasih juga jawabannya.
Okay, sama-sama.
Terima kasih, Alvin. Ada yang ingin bertanya lagi?
I have a question for Miss Azuana Ramli.
Okay.
It was said that linear regression can be used for stock prices, especially in the long term. But the question is, does linear regression can be used at calculating long-term trend in stock, which has exponential growth or decay? Can linear regression use exponential calculation? Thank you.
For exponential, like beside stock trading, I think COVID cases is also exponential. You rarely see COVID cases in linear regression model. So for the exponential, it's most likely we don't use linear regression. Like COVID, in this case, I give COVID because there's current issue right now, and it is exponential. For COVID, we use order ODE, okay, first order model to predict the value. We don't use the linear regression because the data itself is not linear. Okay, for this one, it's more to numerical rather than statistical. So it's outside of statistical lah. So you have to learn a little bit maths on that. But stock trading, I think you don't have to use the ODE for stock trading. Besides, linear is not very accurate. Okay, I suggest for stock trading we use the advanced statistical method like ARIMA, the something statistic model that are related to time movement, moving average. Okay, because linear regression is not moving average. The data is not movement. It's not also based on the real-time data. So basically for the simple model only. So that is the limitation of linear regression. Thank you for the questions.
Thank you, Miss.
Okay.
Oke, baik. Terima kasih untuk Yuda. Ada yang ingin bertanya lagi? Teman-teman juga bisa menanyakan hal lain di luar regression analysis or
boleh.
Maybe machine learning, Dr. Azu, it's okay.
Boleh juga. Boleh. Saya suka mendengarnya.
Learning, ya. Jadi kalau semisal teman-teman ada yang ingin bertanya terkait machine learning, silahkan. Ini Dr. Azu adalah ahlinya or expert in this machine learning. Silahkan yang mau belajar terkait machine learning terlebih dahulu, tidak apa-apa. Karena ini untuk mahasiswa belum dapat materi atau pelajaran terkait dengan machine learning, Dokter.
Oh,
ya.
Sama dengan student saya juga, pelajar saya juga belum mempelajarinya. Semester baru belajar. Tapi saya juga yang mengajarnya. Jadinya videonya saya akan post untuk semester depan machine learning di saya punya YouTube.
Oke, berarti ada YouTube, nanti bisa dicek juga untuk teman-teman yang ingin.
Ya boleh, bisa.
Alhamdulillah. Ada yang ingin bertanya lagi untuk teman-teman yang lainnya? Atau mungkin saya ingin bertanya ini, Dokter, terkait dengan spurious correlation, itu apakah berbeda dengan confounder variable di causal inference atau path analysis?
Bagaimana itu?
Untuk spurious correlation. Nah, what is the difference between the spurious correlation and then the correlation that we study in path analysis, or maybe we call it with structural equation modeling, and also in causal inference?
Okay, the different in here, usually the correlation that we have in our study, the variables data that we have, usually is correlated with each other. So, the spurious correlation when it comes when the variables is not making any sense at all. That is a spurious correlation. There's something out of nowhere. Okay, but basically if the data, as long as in our study, the data is correlated or not correlated at all, it still can be considered as our variables. The relationship between the variables is not a spurious correlation. It's like a special case lah. This spurious correlation is rarely happen. Unless you really want to study what is the chances getting heart attack and sit down in the house, okay, maybe the variables not related at all, but it's suddenly you got the data and you test and you get a higher correlation and you macam tertanya adakah ini variable ini berkaitan kerana correlationnya sangat besar, tapi sebenarnya variable ini sebenarnya tidak berkaitan sama langsung. Itulah the spurious correlation.
Oke, baik, understood.
Okay.
Ada terima kasih Dr. Azu.
Oke, sama-sama.
Ada yang ingin bertanya lagi? Maybe Miss Indah, if you have any. Faras, silahkan.
Yeah, maybe I will use bahasa.
Oke, boleh. Bisa.
Tadi dijelaskan di presentasi ada plot, scatter plot dengan garis regresinya. Apa yang bisa kita simpulkan dari plot itu? Jadi kita bisa mengambil kesimpulan apa dari sebuah plot itu antara scatter plotnya, titik-titiknya dengan garisnya tadi. Itu untuk pertanyaan yang pertama. Yang kedua, saya juga sering mendengar ada yang namanya regresi logistik ya, regression gitu.
Logistic regression.
Logistic regression. Ya, apa yang membedakan itu dengan linear regresi linear?
Oke. Jadi itu saja soalannya?
Ya.
Oke. Terima kasih untuk soalannya. Saya jawab yang pertama dulu. Okey, yang line fit-nya, dengan scatter plot-nya. Okay, scatter plot kita nak tengok, kita mau lihat sama ada variables itu ada korelasi atau tidak. Juga untuk lihat sama ada outliers. Yang paling penting adalah outliers-nya. Sekerana kalau korelasi kita boleh juga lihat berdasarkan nombor coefficient correlation, the R value dia yang kita dapat daripada Phyton ataupun daripada kalau using Excel juga boleh untuk linear regression, so juga boleh dapati coefficient correlation-nya. Tapi kita ingin tahu jika kerananya value korelasi ni sangat senang terjejas jika ada outliers. Jadi ini adalah penting untuk kita tengok scatter plot-nya. Diplotkan sekali dia punya line best fit tu untuk kita tengok sama ada dia punya line best fit tu yang scatternya adalah, okay, saya bagi contoh ini. Mana tadi? Okay, contohnya seperti ini. Scatter plotnya, okay, dengan line best fit-nya kita mau lihat sama ada variable ini adalah mendekati dengan line best fit line-nya. So kalau ini kalau semakin mendekati bermaknanya dia punya scattered is very good lah. Okay, but right now if you can see the scattered, okay, it's become scattered everywhere. Okay, this bawah ini sangat bagus, density-nya sangat okey. Tapi bila tiba di atas dia sudah jadi berterabur gitu. Okay, kita boleh expect outliers from this scatter plot, and kita boleh katakan yang variables ini mungkin ada korelasinya tidak berapa bagus untuk semua ini. Okay, walaupun line base fitnya agak bagus kelihatan itu pada awal saja. Okay, di akhir ini tidak bagus. Kalau line base fitnya ke atas, okay, maybe lebih bagus. Okay, itu adalah gunalah line base fit untuk kita tengok sekali dengan scatter plot. Okay, itu yang untuk soalan yang pertama. Untuk soalan yang kedua, untuk okay. Untuk soalan yang kedua tadi, yang logistic regression dengan linear regression. Logistic regression adalah untuk categorical binary. Dia punya output adalah 1 dengan 0 saja. Manakala linear regression dia punya output equation adalah kita punya prediction is including semua value numerical. So dia adalah untuk value-value macam contoh tadi harga rumah. Okay, manakala untuk logistik sama ada awak mau prediksi sama ada benda itu berlaku ataupun tidak. Okay, contohnya macam saya punya Ph.D punya study, saya menggunakan logistik regresi untuk tahu sama ada currency crisis berlaku ataupun tidak. Jadi saya predik 1 untuk berlaku dan 0 untuk tidak berlaku. Sepertinya begitulah beza simple linear regression dengan logistic regression. Okay, terima kasih.
Okay, thank you.
Okay.
Ada yang ingin ditanyakan lagi? Mungkin Bu Indah. So Miss Indah is one of lecturer in data science technology that also teach about statistical methods.
Okay.
Thank you. Thank you, Miss Ati. Good morning, Mrs. Azu.
Ya, good morning.
Nah, mungkin saya tanya in bahasa. Jadi
bisa.
Sebenarnya beberapa mahasiswa ini sudah menyiapkan banyak pertanyaan, mungkin sudah terwakili dengan yang disampaikan oleh Dr. Azu dari presentasi hari ini. Yang saya tanyakan tentang asumsi dari regresi. Kita tahu bahwa banyak sekali asumsi dari regresi linear, Dr. Azu, tentang normal, kemudian heteroskedastis, kemudian autokorelasi, dan multikolinearitas. Mungkin yang saya tanyakan tadi tentang multikolinearitas. Di contoh tadi ada kasus multikolinearitas, lalu sebaiknya yang kita lakukan itu menghapus sedikit saja variabel itu, atau kita tetap atau kita pilih dengan sedikit tapi yang signifikan saja seperti itu. Ini juga ada perwakilan dari pertanyaan beberapa mahasiswa. Terima kasih.
Oke. Jadi soalannya apa?
Bagaimana yang sebaiknya kita lakukan tentang ketika ada kasus multikolinearitas?
Ya, yang sebaiknya kita removekan saja yang value, yang variables yang enggak significant. Itu sebaiknya lah. Macam tadi contohnya modelnya sangat highest multicollinearity, tapi ada value yang tidak signifikan. Jadinya maybe kita boleh cuba dengan buang variables yang tidak signifikan itu, dan kita boleh cuba run balik. Okay, mungkin kita akan dapat result yang lebih bagus dan tidak highest multicollinearity. Terima kasih. Oke, sama-sama.
Baik, apakah masih ada yang ingin ditanyakan ke Dr. Azu untuk rekan-rekan yang lainnya?
Jika ada yang malu, boleh juga email ke saya. Tidak apa, saya boleh jawab.
Dr. Azu, maybe Nalia or Benedicta wants to ask question. Nalia?
Excuse me, ma'am. I would like to ask a question about the dummy variable trap. What is actually defined as a dummy variable trap, and what happens when we don't resolve it?
Okay, for the example that I showed you just now, the dummy variables, let's say Actually, there is no significant effect if you don't, if you skip this step, remove the dummy variables, it's okay actually. Okay, it's just to be careful. Okay, in my most analysis, I don't exclude the dummy variables, and most of the study, not you have dummy variable all the time. Usually, all the data that you have, you want to use the variables, all that variable that you have. Like for example, the first predicting the house prices. Okay, all the variables are important. So we don't want to drop any variables or drop the dummy variables. Okay, maybe there's no dummy variables at all. So that's what it means. The step actually can be skipped, the dummy variables. Okay, you don't have to worry about that. Okay, thank you.
Thank you, ma'am.
Okay.
Thank you. Maybe we can continue to Benedicta and India.
Yeah.
To deliver the question.
Yes, good morning, Miss. So I want to ask a question about spurious correlation.
Okay.
Spurious correlation, the example mentioned before is about the matters that is really uncorrelated, but if it's the same in the same data set, while we looking for the correlation between each variable, could spurious correlation occur?
Oh, actually, this question similar with the earlier question. In the same data set, is not much likely will be occur because the data set is either is highly correlated or not correlated at all. So it's not going to happen spurious correlation because all the data that we have usually are related. It's very rarely not related unless you have the sudden variables that is out of nowhere. Okay.
Oh, okay. Thank you.
Okay. Thank you.
Thank you. We can continue to Juan to deliver the question.
Yes. Regarding the trend test split dataset, the function.
Okay. All right.
How do we find the perfect ratio for the test size?
This is actually will be explained more if you learn machine learning for classification. For the train and test, there is no perfect or everything. But by default, usually it's 70-80 or 75-25. Usually we don't take more on test. We train, get the more data on the train. For the test, usually we 50% is enough, 25% enough. So it cannot be less than, not too little and not too much. Okay, we use more data on the train, but not too much on test. So it must be balanced, but it cannot be 50-50. So you understand what I am saying. So ia mesti yang macam train tu mesti melebihi yang test. Tapi tidak boleh melebihi sampai lebih macam 90 ataupun 10, tidak boleh. Ataupun tidak lebih kurang macam 60